The Journey to Calculus Part 1. This is actually going to be a review from pre-calculus. We do need this for calculus. If a student is missing those information, the basic foundations, you will find calculus difficult. Most of the time when we work on a new topic and set up the equations, maybe like 25% of it's calculus, but the rest is going to be algebra or trig. And that's what we're going to be reviewing. I'm going to start with the most important formulas that we have, the expanding formulas, the a plus b square formulas. Okay, the a plus b square. This is a square, and I usually like to write it like this: a square plus 2 times a times b plus b square. And this might look easy for some of you, but it's important. Same thing with a minus b square. A minus b squared is a squared minus 2 times a times b plus b squared. That's the other formula we need. Very important formulas. So to apply these formulas, we may look at an example such as m, or the square root of m plus 2 squared. So the formula said, take the first term, square it, plus 2 times the first term times the second term, plus the second term, and square it. So that would give us m plus 4 square root of m plus 4. So you need to simplify to the least possible or the least needed. So let's look now at another example. I want to change the terms in the example. Say we have x squared minus 3y all squared. It would be nice if you can try it first on your own before you see the solutions. That will help. That will help you a lot. And after you finish, you're gonna find out that we got a squared the first one minus 2 times the first one times the second one, and always plus square the second one. So when we square this, we multiply the exponents, and I can review the exponent properties here. We got about 7 of them. X to the m times x to the n, it's x to the m plus n. X to the m over x to the n is x to the m minus n. Any number to the 0 power is 1 except 0. If we have a negative exponent, you must write it in a positive exponent way by bringing it down. X times y to the m, you can multiply x to the m, y to the m. X over y to the m, it's x to the m over y to the m. Xm all n, you multiply the exponents, and we have x over y to the negative m. You can flip that to make it positive. So here what we see, minus 6x squared y, 3 squared is 9, y becomes square. So you square each one of them, the 3 and the y, not just the 3 or just the y. Now other formulas we need to know. We have the x plus y cube. How do we cube this? It's the first one cubed plus 3 first one squared times the second, 3x y squared and plus y cubed. Same for the minus case. So if you have x minus y cubed, so that's x cubed minus 3x squared y plus 3xy squared minus y cubed. They alternate plus minus plus minus. And we may look at an example to see how to apply this. We have 2m minus n all cubed. What does that give us? The first one, you cube it, minus 3 first one squared times the second plus 3 first one times the square of the second plus the second one cubed. And then you have to simplify this. We can't just leave it like that. So how do we simplify something like this? You cube the 2. 2 to the third power is 2 times 2 times 2, 8. M cubed minus, this is 4m squared, times 3 is 12m squared, and n. This is 6mn squared plus n cubed. Factoring x squared minus y squared. This is x minus y, x plus y. That's called difference of squares. Very important stuff. So to apply it, let's look at an example. Say 4y squared minus 9. Another example, 1 minus 36x squared y squared. And let's go over the first one. Always pause the video and try on your own first. You can rewrite this as 2y squared minus 3 squared. Now it's 2y minus 3, 2y plus 3. Here, same thing, 1 squared minus 6xy squared. That gives us 1 minus 6xy, 1 plus 6xy. We got more factoring. We have the cubic one, x cubed minus y cubed. The formula said, the way I memorize this is I cover the exponents, that gives me x minus y. Then you square x, switch the middle sign, multiply them together, plus y squared. X cubed plus y cubed. This x plus y times x squared minus xy plus y squared. That's the sum of cubes. The previous one, difference of cubes. So example this, let's say 8x cubed minus 1. We need to factor this. Factor means write as a product of factors. So this looks like the first one by rewriting this first as something cubed minus something cubed. 1 goes there. The 2, if you cube it, you get 8 and x. So you get 2x minus 1, then 4x squared plus 2x plus 1. Another way for factoring is to take out the greatest common factor, GCF. For example, let's say we have 8x squared minus 12yx, or let's say 5k cubed minus 15k, or let's make it 5k. The common factor among 8 and 12 is 4, the greatest common, x squared and x, no y's, so that'll leave 2x minus 3y. For this one, we can take a 5k out, that will give me k squared minus 1. But notice I can factor further here by writing this as k minus 1, k plus 1. Other forms of common factoring could be 2, let's say 2 times y plus 3. So we're learning and reviewing the concepts by using examples. Say something like this. What is common? This by itself is one term, and this is another term. So what is common among these two? I see y plus 3. What is left inside? 2 times y minus 1 plus 3 times y minus 5. And that gives us y plus 3 stays the same. 2y minus 2, 3y minus 15. So that gives us y plus 3, 5y minus 17. Another example similar to this, let's say 15x cubed, x minus 3 squared times x plus 1, minus 5x squared times x minus 3, x plus 1, and x minus 4. So we got two terms. Terms are always separated with a plus or minus sign. Plus or minus sign. So this is one term, this is one term. What is common? The 15 and the 5 is the greatest common factor. X cubed and x squared is a common factor. X minus 3, we got x plus 1, and that leaves 3x, x minus 3 minus x minus 4. What is left? This stays the same. X minus 3, x plus 1. If you multiply everything out, we get 3x squared minus 9x minus x minus 10x plus 4. If in case we are asked to solve this equation, so how do you solve such equation? So let's say we need to solve this equal to 0. So you get 5x squared is 0, x minus 3 is 0, x plus 1 is 0, 3x squared minus 10x plus 4 is 0. So here we get x is 0 because 5 cannot be equal to 0, x equals 3, x equals negative 1. These are called roots or zeros. This one, if you do trial and error like this, factoring or any other method, is not going to work out. So how are we going to solve this? To solve this, let's recall the quadratic formula. If you have a quadratic equation in this form, then x equals negative b plus or minus the square root of b squared minus 4ac over 2a. This is called the quadratic formula. So I can apply it to this equation. So x equals negative b, so negative 10 plus or minus the square root of b squared minus 4a times c divided by 2a, 2 times 3. So x equals 10 plus or minus the square root of 100 minus 16 by 3, 48. So 100 minus 48 divided by 6. That would equal to 10 plus or minus square root of 52 over 6. If you leave the answer like this, you may lose points because it's not totally simplified. Notice the 52 is 4 times 13 over 6. That's a plus or minus. You can take the 2 out or the 4 out as a 2. X equals, take a 2 out, 5 plus or minus the square root of 13 over 6 by 2, 1 by 2, 3. So that gives me x equals 5 plus or minus square root of 13 over 3. So we get all the answers that I boxed. Those are called roots of the equation, roots or zeros or solutions. They all mean the same. Now we can look at more factoring, something like 3x plus 1 to 1/3 plus 3x plus 1. When we take the greatest common factor, that would be the greatest factor that can be common among the 2 or more terms. Here, this is 1/3 as an exponent. This is 1. We always take the smaller. So 3x plus 1 to 1/3 is the smaller. So what is left? Here there should be 1 plus, because this times this gives me the first one. Here should be 3x plus 1 to what power? So if you multiply this by this to give you 1 is what? I already have 1/3, so I need a 2/3. 2/3. So that's all you need to do here. You can't factor more. That's the best you can factor. And we need these things later on when we are working on a calculus question at some point. We do need to know how to apply this. The next part is we recalled the exponent properties earlier, but we need to simplify or apply them by simplifying. Say negative 2x to negative 3 all square, y to the 5th all to the 3rd divided by 8x to the 4th square, y to the negative 3. So how do we simplify such expression? Okay, so how to simplify such expression? To do so, we keep the negative 2 out, multiply the exponents, x to the negative 6, multiply the exponents, y to the 15, 8, x to the 8, y negative 3. Then what do? I see negative exponents. First by 2, 1, by 2, 4. I see negative exponents. We cannot have negatives. So if I want to get rid of the negative, I just bring it down. I want to bring this up. So that gives us negative y to the 18th, 4x to the 14th. So if someone gives you something like this simple, y to the 6th, to simplify something like this means combine like terms. If no terms to combine, you can just get rid of the negative sign. We can't have negative signs in the final answers. Everything must be positive, because later on in calculus, it will help us to have everything in positive. Also, another thing good to review, fractions. How to work with fractions. Let's say I want to simplify, or I'm asked to simplify something like this. So what do we do with this one? I want to combine them. To combine them means we need to find the least common denominator, LCD. So how do I find the LCD to this? Well, I keep this the same, nothing can be done. But here I can factor the y out. That gives me y plus 3. Then keep this the same. What's the LCD here? The LCD that I'm going to write on the side, I see y is common and also y plus 3. So in the second fraction, I have everything done, but I'm missing here y plus 3. So I multiplied here and on the top. What does that going to give us? Keep the y times y plus 3 the same. On the top, you get 2 times y plus 3 minus 1. So then this is 2y plus 6 minus 1. We always keep the denominator the same. Sometimes you end up factoring the top and simplify it with the denominator. So we always keep denominator the same. We don't have to multiply it out. On top you get 2y plus 5. That's all we need here. So factoring is very important. Expanding is also very important. We will be using those in calculus throughout the course. Working with fractions, adding, subtracting, multiplying, dividing, all these things will be needed. So this is the first part of the journey to calculus.